Today we are going to discuss about bipolar junction transistor. Actually, it was invented in 1948 by Bell Laboratories. It's a three-terminal devices. Here, each of the terminal has its name, emitter, base, and collector, and we are going to discuss it later. Actually, it plays a crucial role in various electronic circuits, from amplifiers to switches, and understanding of BJT is extremely important because after the fire, transistor is something that changed the scenario of the whole world. And if you're interested in electronics or computer science, you can't simply ignore this topic. And now we are going to see what's inside this black box. And actually it's a sandwich like, let me draw this. It's a sandwich of three different semiconductors. First one is N type, then a P type, and then again an N type, or it can be P type, then an N type, and again the P type. Now both of these have different terminologies. First one is the NPN transistor and second one is the PNP transistor. And in NPN transistor, we call it this region a emitter. Let me grab another color. Emitter, and this one is base, and this one is collector. Metal heads are connected here, and in this base region it's here, and this one here. And in a PNP transistor, here metal heads are connected, and we call them again emitter, base and collector. Here we see there are two different junctions. First one is the EBZ, emitter base junction, emitter base junction, and second one is called collector base junction, or CBZ. As it's a PN junction, it can be biased in forward or reverse manner. According to the biasing configuration, we can call the transistor is operating in 4 different modes. Just think about it's EBZ and CBZ. If both of them are in reverse bias, we call it a cutoff mode. Pardon. If emitter base junction is forward bias and collector base junction is reverse bias, we call it active mode. And if both of them are in forward bias, we call it saturation mode. Most of the transistors are operated in active mode, where EBZ junction is in forward bias and collector base junction is in reverse bias. And the circuit symbol of a transistor is this one. It's emitter, base, and collector, and we place the arrow in emitter base terminal, and if it's PNP, okay, fine, PNP, then the arrow goes from P to N, and P to N. And if it's an NPN transistor, if it's an NPN transistor, NPN, and the terminals are E, B, and C, so again the arrow goes from P to N, P to N, P to N. So we will understand from the circuit symbol which type of transistor it is. And there are also maybe another, actually there are another mode which is called reverse active mode. If EBZ junction is in reverse bias and CBZ junction is in forward bias, we call it reverse active mode. Reverse active mode. Active mode. And now we will discuss about a operating principle of a BJT in active mode. Okay, now we draw a transistor here, and this one is our emitter. This is base and this is collector. So emitter base junction is for forward bias, and just imagine it's an NPN transistor, and to connect emitter base junction in forward bias, and our circuit symbol should look like this, and to connect collector base junction in reverse bias, we have to connect our cell this manner. Now just focus on this junction. In this junction here, our majority carrier in this N region is electrons, and minority carriers are holes. And in P region, majority carrier are holes and minority carriers are electrons. Now the number of electrons in N regions are comparatively higher than the number of electrons in P region, and N region is lightly heavily doped and P region is lightly doped. And when we connect our cell in this manner, like in EBJ junction is in forward bias, then we see that we see a lot of electron here. We call them injected electron. Now this electron cross this potential barrier, which is close to 0.7 volt, and reach this base region, and some of electrons recombines with the holes in this P region, but their number are so small, and other electrons actually diffuse throughout this region. Like we will see so many electrons here, electrons, and we call them diffused electrons. And these diffused electrons come here, and due to this larger potential of positive voltage, this electron actually swept through this junction, and here we see a greater path created, and this way electron travels from this way to here. A small amount of electron actually follows this path, and for this electron the current we call it base current, IB, and some amount of holes also reach from here to here, from base to emitters, and this also contributes to our total current, which we call its IE equals to IB plus an IC. So here is the total operating principle of a BJT. Thank you.